Madam, shall we start, ma'am?
Yes, sir.
Okay.
So, good morning to all. Once again, I welcome everyone for this third day of first session of ATAL FDP program. I welcome our resource person, Dr. V. Kanthasamy, sir. He is an associate professor of Department of Triple E, Kumaraguru College of Technology, Coimbatore. He completed his UG degree, BE Electrical and Electronics Engineering from Kumaraguru College of Technology and at Bharatiyar University in the year 1998. After that, he completed M.Tech in the field of VLSI design from Sastra University, Tanjavur in the year 2003. After that, he completed his doctoral degree under Anna University in the year 2016. He started his career as a lecturer in Bannariyaman Institute of Technology in the year 1999. After that, he joined in Kumaraguru College of Technology as a lecturer in the year 2002 till he is working in Kumaraguru College of Technology as an associate professor. His project are shortlisted in AICT, CII, and Innovative Project Contest in IIT Kanpur. He received an fund under MODROPS scheme from AICT in the 8 lakhs 40,000 for modernization of electrical machines lab in the year 2017. He has totally 14 publications. He published one Annexure 1 Scopus journal, and he's published 6 Annexure 2 journals, and he published in 4 international journals, Thomson Reuters or Scopus journals. He presented 10 papers in international conferences and published one paper in IEEE Explorer. He has attended many faculty development programs, and he is taking care of many responsibilities in department and also institution level. With this, an excellent academic and administrative responsible person as a resource person for our ATAL FDP program. It is my honor and privilege of welcoming our resource person, Dr. Kandasamy sir. I welcome you, sir.
Thank you, madam.
I hand over the session to sir.
Good morning, participants. Sorry for the delay due to some technical issues. Okay, we will start the session. So, this FDP session, we will see the Indian energy scenario, demand and supply, electrical vehicle technology, government subsidies and policies, future in EV, electric vehicle technology. So today we will see the terms and basic definition of the energy, types of energy, environmental issues, Indian power scenario, energy conservation, sector-wise consumption, energy management, and BEMS, Energy Conservation Act. Ma'am, you can change your slide from first to second. Shyamala, ma'am.
Yes, sir.
Energy Conservation Act and efforts, energy saving tips in home, history and working of electric vehicle, e-vehicle policies and subsidies. All these topics we will discuss. So you are all the faculty members in various institutions. So you know very well about the what is energy, what are the different types, everything. Just I have to refresh very quickly. Then we can go to e-vehicle and the scenario of the Indian e-vehicle sectors. So normally the energy is defined as the ability or capacity to do the work. So these energy can be taken from either a conventional or a non-conventional system. So in olden days, the water pumping can be done through the pedaling system. There is no electrical utility. We can only use the mechanical man force or some animals we can use for the purpose. Next slide. So also The people learn to use the chemical energy stored in a material. Next slide, ma'am. Like chemical energy stored in a materials like wood to cook and heat their homes. So next slide. So due to the technological advancements, the industrial revolutions, so in late 18th century requires the use of the energy resources, especially the fossil fuel. So either coal, diesel, petrol, nuclear fuels can be utilized for production of the power. So we know that there are two types. One is the renewable energy, another one is a non-renewable energy. The energy obtained from the natural sources like sun, wind, solar system, windmills, these are all the renewable energy. The non-renewable energies are, it can be not like coal, petrol, diesel, these are all the non-renewable. So these things can be almost 80 percentage of electrical utility or energy can be generated through the non-renewable energy sectors. Nowadays, the government of India and state government are encouraging to do the non-conventional or non-renewable energy renewable energy sources, like we can use the solar plant, windmills, or thermal plants, all these hydro plants. The non-renewable have the thermal power plant using the fossil fuels such as coal, petroleum, oil, natural gas. Then we have a nuclear power plants. These thermal and nuclear plants are having the some drawback due to the environmental pollution. Then the fossil fuel uh, capacity will be reduces day by day. Almost 60 percentage of the fossil fuel can be used uh, by the whole world. Remaining we have only the 40 to 35 percentage. So we will go our life along with the 30 to 40 percentage of the fossil fuel. Therefore, all the governments are concentrating on the non-conventional sources or renewable energy systems. So these renewable energy system convert the energy for, available in the sunlight, wind, falling of water, sea water, other geothermal or then geothermal heaters, biomass. These are all the different ways of renewable energy can use to generate the power, generate the electricity. So these renewable energy examples are solar, wind energy, hydropower, biomass, geothermal, tidal, wave energy, ocean thermal energy. So the solar, so in India, due to the climatic condition, we are having the very high potential of the solar energy. Therefore, the government of India now concentrating more and more solar plants. Now in southern India, South Tamil Nadu, we have a 1 megawatt of solar can be installed by the um, Adani power sector. So similarly, we have a different topologies for the wind energy mills, either a horizontal wind turbine, vertical wind turbines, all these things are available. So then we have a hydropower. The hydropower can be of the availability of the uh, water, and the availability of the head of the water is very, very important. So these are all the different categories of the renewable energy examples. So these energies can be utilized in India. So we will have the proceeding slides having the what are all the percentage of energy utilization from non-renewable and renewable energies we will see later. So my voice is audible, dear participants.
Yes, sir. It is very clear. No issues, sir.
Okay. So these non conventional sources are the environmental issues are energy and environment, greenhouse effect, global warming, ozone layer destructions, acid rain formation, radiation and health issues. So these are all the environmental issues by utilizing the thermal plants and the nuclear plants. So it is producing the carbon dioxide more and more automatically. Uh, the environment will be polluted. So this is a power capacity in India. So this the the power rating can be taken in the 31st March 2020. So we have a coal, that is a coal is a thermal plants is the only the is a 55 percentage or 55.4 percentage. So almost the 50 percentage of your electrical energy can be taken or generated from the thermal plants. From the coal, we can have the 55 percentage. Then large hydro plants are 12.3, small hydro plants are 1.3 percentage. Large hydro plants like so, especially in a Mettur Dam is almost the large hydro plant. The small hydro plants we can have the Kunda, the Nilgiri Hills we have variety of hydro plants or small hydro plants are available. So such kind of hydro plants are the capacity is a 1.3 percentage. Wind power is 10.2 percentage. Almost the wind power is equal to the large hydro plants. You can compare. Then the biomass is the very least one, that is the 2.7. Then the growing technology called the solar plant are 9.4 percentage. The compared to the wind power, installation cost, the solar power plants are very less compared to the wind and hydro plants. Then the nuclear is just 1.8 percentage, gas 6.7, the diesel is 0.1 percent. This is the distribution of uh, power taken from variety of plants are available in India. So the electricity sector of the India, the electricity coverage 99.7 percentage be covered in India. The installed capacity is 3,71,054 megawatt. The through the fossil fuel it is around 80 percentage. The renewable energy is around 17.3. Average electrical utility is 1181 kilowatt hour per capita. The transmission and distribution losses are 21 percentage. The residential consumption is 25 percentage. Industrial 41, agriculture consumption 17.7, commercial consumption is 8.24. This is a whole India power distribution. The installed capacity 3,71,054 megawatt. So to generate the power is equal to saving of 1 unit of generated power is equal to saving of 2 units of energy. This is a normal slogan. So the energy conservation is very important criteria for in any energy sector. The energy conservation is the practice of decreasing the quantity of energy used in the same quality of the output. It may be achieved through efficient use in which the case energy used in decrease while achieving the similar outcome. Energy conservation also includes prevention of misuse of energy. Nowadays in northern India, we have a power thefts are there. The overhead transmission line is going on. So the agri peoples or industrial sectors are easily tap the power. Thefting of power is there. Why we can conserve the energy? We will limited resources. Already I explained. In available earth, we used 60% of the fossil fuels are utilized or used one. We need to sustainable growth and save the resources for the future generations. The energy conservation is the one way to achieve this. Our electricity bill becomes less. The thermal plant shares about 65% of total electricity, not a 65, it is a 55%. These thermal plants are generate the poisonous gases such as carbon dioxide, carbon monoxide, nitrogen, sodium. So these are all releases the atmosphere, causing the environmental pollution and affecting the ozone. So this is the sector-wise power consumption. So these things already we know very elaborately. Agriculture sector, residential, transport, the others, industry, everything. So conservation of energy at various levels. The energy conservation at household that can be possible. Conservation at the industrial people places. Conservation through the transportation sectors, community level, common areas we can conserve the energy. So these are all the various places. So the energy management is a term used to save or reducing of the energy in business, public sector, government organizations, and home. So there are five key benefits for building up of energy management system. BEMS is a building energy management system. There are five key points. So the Energy Conservation Act was introduced in the year 2001. The EC Act can be again reformed for 1st March 2002. Bureau of Energy Efficiency, that is BEE, also introduced some standards for the 1st March 2002. Some of the features for the Energy Conservation Act evolved minimum energy consumption and performance standard for notified equipment and appliances. Because the energy losses due to the consumer side also is that non-proper utilization of the uh, equipment, like motors are consuming more power or the losses will be more, motor losses are more, then we can unnecessarily using the resistive heatings, unnecessarily using the fans, refrigerators, air conditioning system. So these are all due to the application wise, the energy consumption will be more as well as the losses will be uh, increases. Next one, the prohibit manufacture and sale of equipment and appliances not comfort conforming to standards. Nowadays, in the refrigerator, washing machine, air conditioning machines, these things having the some star rating, 5-star rating, 4-star rating. So the star rating increases. So it is a energy efficient equipment. So it will consume less power and the output will be more. Likewise. So next one is the introduce the mandatory to labeling to enable consumers to make informed choices. So the Bureau of Energy Efficiency, the important roles are implementation of provision of Energy Conservation Act, quick coordination, policy research, promotion of energy efficiency, development of new financial instruments, awareness creation, publicity of the BEE rules, electricity conservation act. These things can be published in a web portal or whatever it is. The Energy Conservation Day is India is observing 14th December every year is observing the Energy Conservation Day to create the awareness of conserving the energy to the people and industrial sectors, whatever it is. So this is a comparison chart for some of the household articles, how it is utilized, what is the saving of electricity, everything we can have. Then we can quickly shift it to the e-vehicle and e-vehicle scenarios, all these things. So the energy efficiency, so we have a light emitting diode, LEDs, next to incandescent lamp. Then we have a CFLs, compact fluorescent lamps. In earlier days, the people, many houses having the incandescent lamp. This is almost the resistive load. The lifespan is averagely, the LED lights are 50,000 hours. Incandescent lights are 1,200 hours. The CFL are 8,000 hours. So compared to the CFL incandescent lamp, we can preferable for LED lamps. Then the power rating of these components or these utilities are for LED are 6 to 8 watts. Incandescent lamp, we have variety of wattages are available. 60 watts, 40 watt, 100 watts, 200 watts bulbs are available in the market. Similarly, the CFL also we have a 13 to 18 or not 24 watts CFL also available in the market. Then unit of electricity 329 kilowatt hour per year. There are 30 incandescent lamp per year equivalent. Next one is a 3,285 kilowatt hour per year. The CFL is the 767. So compared to all these things, the power rating or power utility or conservation of power is in LED lamps. Annual operating cost is 1,316 per year. It is 13,140. CFL are 3,068 rupees per year per annum. Okay. The energy saving in a motor, we can have the oversized motor, rewound motors, improper voltage, less efficiency motor, ideal running. So these are all the different problems. So how can we conserve a power from home? So these are all the electrical utilities are utilizing in our home. One is a fan, switches, coolers. Then we have a dishwash, washing machine. Uh, then okay, so we can categorize for good, better, and best. So the first one is using ceiling fan in rooms when you. Next one is compared to the table fan and the ACs, we can use the ceiling fan. Next one is a close. The curtains can be open, the windows. Then you can turn off your switches, lamps, and or any electrical products while you can away from the room. So this is a good habit of energy conservation. Another one is the better one is the delay, not a delay, it is a dishwash can be utilized in overnights. Wash the clothes in cold water. Somebody can be used for options for 40 degrees centigrade or 30 degrees centigrade for hot water. So such kind of washing machines can be utilized more power, more time to work, all these things. So these are all the different methods to save the energy or conserve the energy in a home itself. So these are also some of the tips. Wash only full loads of dishes and cloth. Wash cloths with cold water. keep your appliance clean, keep your oven door closed while cooking, that is electric oven. Don't stand in front of any open refrigerator doors. Automate your appliances with smart assistants, air dry cloths, air dry dishes instead of using your dishwasher's dry cycles. Open the curtains facing in sun. Bring more natural light with the mirror and bright walls. So these are all the some of the glitches for consumption of power from home itself. Adapt your daily energy habits. Switch out your incandescent lamp. Take shorter, cooler showers. Turn off electronic appliances when you unplug battery charger when not in use. So almost 99% of people are using the same thing, unplug battery charger. Adjust your device and appliance setting to save energy at home. Adjust your thermostat according to the time of day. Lower the thermostat on your water heater to 120 Fahrenheit or 48.89 degrees centigrade. Set your computer to sleep mode. Avoid using the resin and hold setting in your dishwashers. Next, consider using the energy saving alternative. Use microwave oven or toaster oven instead of your conventional oven. Use dishwasher instead of washing by hand. Use your electric kettle to boil water instead of micro oven. Make small invent to achieve long-term results. Plug home electronic into power strips. Install low-flow shower heads. Add aerators to your home. Add insulating blankets to older water heaters. So these are all the some of the tips to improve the energy conservation. So you can use the electrical equipment like the star rated equipment like for either refrigerator, washing machine, air conditioning machine, whatever it is. Then the lamps can be preferable for instead of CFL and incandescent, we can use the LED lamps. Replace older home appliances with the energy efficient models. Use energy efficient entertainment and home efficient electronics. So these are all the some of the tips. Prevent leaks in your home. Insulating heating ducts, seal air leaks, insulate hot water pipes. These are all the way to save the energy. Now we can move to electric vehicle technology. What is electric vehicle? Okay, before that, so far we saw the different power generating stations. The seed for power generating stations are either a uranium thorium for nuclear plant, uh, coal, coal, diesel, petrol, or the thermal plants. So these are all the fossil fuel. Almost 60% of the electrical utility from India itself is only the fossil fuel. The remaining 40 percentage or 25 to 35 percentage is the non-conventional sources. In that we have hydro plants are almost consuming gives the 13 point some 3 percentage of power. hardly we can have the 20 to 25 percentage of power from non-conventional sources. So the conventional system, the like your fossil fuels are reduces almost 60 percentage of fossil fuel are already extracted from the earth. So we can have only the 40 percent we will consider about our future generation uh, peoples. Therefore, hardly the power or energy utility is one way is a transportation, either a diesel or petrol. So that replacement of the diesel petrol for transportation, the peoples or inventors are chosen for a electric vehicle technology. Instead of diesel engine or petrol engine, we are using a motor, electric motor to drive the driving system. This is the simplest way. Why we can go for electric vehicle? One is a pollution, capital cost and maintenance cost, availability of fuel, uh, well well to wheel efficiency. The efficiency also one of the point. The pollution according to USA DOE Department of Environment USA, they are having the some statistics around the pollution. The transportation account for one third of all energy usage. Almost 33 percentage of energy generation can be utilized by the transportation. That is the meaning. 10 percentage of ZEV cuts 1 million tons per year for air pollution. With 100% EV, carbon CO2 emission would be cut off by half. So at the introduction of the windmills, the carbon credits are very much popularly speaks because by utilization of the uh, renewable sources, available so natural available sources, the emission of CO2 will be reduced. So automatically the pollution or environmental consideration will be well taken. The capital cost and the maintenance cost, EV having more capital cost. Yes, the cost of the EV vehicles, almost two-wheeler having the 1.1, 1 lakh 10,000. The car are very high cost, but the life cycle cost in EV electric vehicle is very less compared to the IC engine based vehicles. Next one is the availability of fuel. Already I explained for 60% of fuel is almost sucked by the uh, consumers. The remaining we have only the 30 to 40%. We can leave this 30 to 40% for our future generation. Therefore, we can go for EV. That is a faster depletion of fossil fuel depending on Middle East countries. This is the very big problem or threatening in government of India. So we are purchasing uh, diesel or petrol from the Middle East countries. Uh, we are almost for 40 percentage of our economy is losing the due to the consumption of the petrol and diesel. Yes, already we know the electric vehicle is a following features having the portable energy source, traction effort provided by the electric motor. The traction effect means the rotational energy can be created by a electric motor. So we have a battery system, the electric motor, some the mechanical features are also there in a electric vehicle system. There are many types of electric vehicles are there. Normal electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle. Hybrid electric vehicle means, so normal electric vehicle we can have the battery and motor. Whenever we need to charge, we can charge. The hybrid electric vehicle means we have a battery with the solar panel. The mixing up of two technologies. So that is a hybrid electric vehicle. Then plug-in hybrid electric vehicle. This hybrid electric vehicle with the chargeable one, we can able to replace the battery swapping. So these are all the various ways or various classification based on the construction of the EV. So these are all the components of an EV. One is a battery, power converters, electric motors. So each and every category we have the lot of researches are going on. So fast charging of battery, long life of battery, mm, maintenance free batteries are available in the market. So the research is going on in these areas. Those who are not registered PhD, you can concentrate the battery management system in a vehicle. We can have the wide opportunities. So the battery, the power, so the batteries gives the supply to the electric motor. Its capacity is defined as a ampere hour. The design of battery includes complex calculations which determines various battery parameters, all these things. Next one is a power converter. In the power converter, the battery gives the fixed voltage or sometimes it is a variable voltage. But in an electric vehicle, the speed control can be done only the voltage controller of DC motor. The armature voltage reduces, automatically speed will reduce. Armature voltage, input voltage increases, speed will also increase. So these power converters are plays a major role for e-vehicle. The conversion of the fixed DC voltage into the variable DC or variable AC depends upon the what type of motor you are using in a e-vehicle. E-vehicle motor is a DC motor means so that the fixed DC to the variable DC. If you use the e-vehicle as a AC dependent one means you can convert the fixed DC to variable AC. There we can have the DC to DC converter. Then we have attached with the inverter. Then we can have the so by adjusting the duty cycle of the power converters, automatically the voltage will vary. So your speed of your electric vehicle will be regulate. Then we have an electric motor. The DC series motor, induction motors were used at the earlier stage of the electric vehicle. Now it is shifted to the special electrical machines like BLDC motor, uh, permanent magnet DC motors. So these are all the different motors. Next we have the components in EV are the clutch. The engine must decoupled from the wheels to shift from low speed to high speed gears and vice versa. So nowadays it is not a belt drive. We can have the motor can be directly coupled with the geared arrangement of system. If the motor rotates 1 RPM, automatically the gear may be in a 10 or 5 RPM to speed up. So the geared concept, we can have the increase the speed of your vehicle. That can be possible. So that's why the next task is the transmission. The gearbox is also called as a transmission, which allows the transfer of power from engine to wheel. Next one is the drivetrain. The combination of electric motor, clutch, gearbox is referred as a drivetrain. So this is a basic architectural of electric vehicle. So that is a source charger. It is a plug-in charger. We are having the charge the batteries, charge the battery. So normally the battery is a DC potential. The input and output also a DC. Then we have a power converter. This power converter may be a DC to DC converter or DC to DC converter with inverter, whatever it is. Because this motor is a DC motor, means it is definitely the DC to DC converter. The motor is a AC motor, means we have a DC DC converter and a inverter. So here the drive control signal. Here we are the power converter having the PWM can be controlled by the clutch. By accelerator we can give the acceleration. Automatically the PWM controller will increases. The duty cycle can be improved. The voltage generation in the power converter output also high. The electric motor speed will fast up. The that can be transferred to the drive shaft and wheels, all these things. So this is an architecture of a e-vehicle. Next we have a plug and charges in USA. We have a level 1. Level 1 is a residential charging. So we can, in United States, it is not in a 230 voltage system. It is a 110 or 120 voltage system. Therefore, it is a 120 volt AC 15 amps. It is a typical household residential charge station. The level 2 preferred method for battery in electric vehicle charger, both private as well as the public facilities. It uses the 240 VAC, the single phase 10 to 40 amps rating. The conversion from AC to DC takes place through the rectifier and a board. This is the level 2 charge station introduced by the Tesla. The Tesla is the number 1 company for manufacturing the e-vehicle, normally the vehicle. So especially they are concentrating much on the e-vehicles by the Tesla. The level 3 charging stations are a fast charging for commercial and public applications. We can have fast charging of mechanism is very essential for reducing the transportation time. It uses an off-board charge station service by 480 VAC or 3-phase circuit. It converts from AC to DC through done in off-board. It is a fast charge station by Tesla Motors. So this is instead of petrol bunk, just you can see this is just like a petrol bunk structure. We have a stand and this is the charge cable. Instead of diesel or petrol, here we have electricity can be converted into a AC to DC, so with the high current rating. The battery is quickly charges to the batteries available within the car. So next topic is the electric vehicle scenario in India. We will see in India as well as the Tamil Nadu. So the electric e-vehicle policies in Tamil Nadu we will see in the last. Why India should go for EV? Yes, not only India, yes, especially in India. So we have very less potential of diesel and petrol wells are available in India. This is the drawback of Indian scenario. So, but we will have quite amount of coals are available, thermal plants are there, hydro plants are there, then the wind and solars are potentially we have, but the diesel and petrol wells are not available. In India, we have a ONGC, Oil Natural Gas Company, by the government of India. It is a public sector concern. So they are researching the places where we have a sufficient amount of the petrol or diesel or gas plants are available. So we have a quite, based on the demand and the supply capacity, we have very very small amount of um, petrol and diesel. We depend only on the Middle East. This is the first drawback. So that's why the second term of Indian Modi government, so they planned for e-vehicle concept. In 2025, almost the two-wheelers, rickshaws, autos, all are converted into the electric vehicles. Automatically, we can able to reduce our, improve our economy and reduce the number of liters or import percentage can be reduces. Automatically, our Indian economy will, GDP will goes up. So that is a thing. So in India need to reduce the dependency of fossil fuel based economy. India's crude oil import in 20 to the 14-15 was 112 billion dollar. Approximately it is a 7 lakh crores. Aspects related to global warming need to shift automobile solution to reduce. Yes, another problem is global warming. These fossil fuel based vehicles produces more and emission of more and more of carbon monoxide. Automatically, it will emit the gases. The global warmings or need increases. The can be ozone holes are increased. Diameter will be also increased day by day. So these are all the problem. In at a whole, the environment problem. Next one is the cost wise. That diesel and petrols are very high. Day by day, they are revising. This is the problem. Then the due to the environmental pollution, the air quality will be spoiled, polluted. So last year, before Corona, we will for last 3 years we saw the news, and especially the Delhi we have the air quality problem. So air is almost completely it is a polluted one. So we can stop the vehicles for a period of 4 hours or 3 hours. Likewise, they are doing in Delhi government, especially in the capital of our India. So these are all the problems why we are not using in why we are not. So the air quality increases due to the automobile sector. India can become a global provider for clean mobility solution and process that are affordable and scalable. People live in some of the Indian cities are being affected by the noise pollution. Some of the Indian cities have the worst noise pollution level in the world. Electric vehicle may contribute to reduce the noise pollution level in these cities. Energy efficiency and the emission reduces has improved the automobiles, but the energy efficient measures and the pollution control measures did not keep pace with the sale growth in vehicles. This is the current status of the e-vehicle in India. Indian e-vehicle market is very nascent stage, comprising only the 1% of total automobile sale. 95% of Indian EV market is dominated by two to two and three wheelers. Yes, two wheelers. Sometimes we can have the autos and mini autos. EV market in India is about 25,000 unit at the end of 2016-17, 56,000 units at the end of 17-18, 4,330 EV were sold in Gujarat, 2008 46 in West Bengal, 2004 67 in Uttar Pradesh, 2003 88 in Rajasthan during the financial year of 16-17. EV market in India set to enter of flurry of new players of foreign and domestic origin in the 2 to 3 wheeler segments. So nowadays, slowly it is growing environment, growing field for two-wheeler as well as the for the three-wheeler. Nowadays, a common man also thinking of the two-wheeler through the e-vehicle technology can be buy. Chinese firms such as the BYD Co. Auto Company Limited will supply the electric buses to some state transport from Mahendra has the first to launch the market. The advantage of four-wheeler segment, the company planned to make 60,000 e-vehicle annually from 2020. The Indian unit of South Korea, Hyundai Motors, expected to launch the electric vehicle in 2019. Maruti Suzuki will enter the market by 2020. The Motors has launched in the e-vehicle Tata Tiger is in 2018. So this technology is slowly growing, but it is not in a boom because of the COVID problem. Some of the companies are thinking of launching of their industries within the government, within the India. So some of the challenges are there in EV market in India. So the global EV HEV means it is a hybrid electric vehicle market. Then Indian EV market and the challenges, the recommendation and the iteration. So the global market, the case of change, why alternative powertrains, why HEV or normal EV, global demand and policies, global technology evolutions. These are all the global um, perspective of the business in e-vehicle. But in India, extensive primary research across the industry, government, consumer interviews, qualitatives, feedbacks, uh, all these surveys can be done from the consumers, different kind of consumers, group of consumers, or individual consumers, or a valid consumers. We are going to have the feedbacks, the consumer acceptability, detailed consumer research insights, production capability, price performance evolution in Indian market. So the peoples are asking the price is the first priority. Next one is the performance. So we can no need to compromise the performance with the price. The technology capability uh, importance of technologies for the India's right to win, infrastructure requirement, power charging stations. So the power and charging stations can be given by the government sector only, not in a private professionals. So next we have a potential for hybrid electric vehicles. The recommendation and interventions are the policy framework unlock XEV potential, demand, incentives, supply incentives, R&D, infrastructures. These are all the way we are going to concentrate to develop the e-vehicles popularly. Next, cost benefit analysis and the challenges, net present value, fuel saving, investments, all these things are cost analysis of the vehicle. Suppose we are going to launch a vehicle, so by purchasing of such kind of vehicle, you are going to save such this amount of liter of petrol. This is a thing. The individual part cost also very less. You can advertise or you can preamble to the consumers. So these are all very essential. So these are all the recommendation given by the global market. The net benefits from EV are fuel security, carbon dioxide emission will be completely arrested. Uh, yes, the last one is a job creation. More and more of Mechanical and electrical engineers will be placed in this new sector. Not only engineers, diploma holders, IT persons can have the more job opportunities. Government initiatives for promoting EV in India. In 2012, the National Energy Mobility Mission Plan (NEMMP) 2020 was established to promote hybrid electric vehicles under NEMMP 2020, an incentive scheme faster adaptation of and manufacturing of hybrid electric vehicle by FAME Phase 1 and Phase 2 programs. Was launched in 2015 to reduce the upfront purchase price of hybrid electric vehicles to stimulate their early adaptation. In early 2018, the Ministry of Power launches the new National Electric Mobility Program to focus on creating the charging infrastructures and the policy framework to set target of more than 30% electric vehicle by 2030. That is a now 2021. After 9 years, almost the 100% vehicles becomes 30% will be the electric vehicle. Remaining 70% will be the traditional way. The program will be implemented by Energy Efficient Service Limited. EESL will arrange demand by procuring electric vehicle in bulk to get economies of scale. Ministry of Power has notified the charging infrastructure of electric vehicles guidelines and standards on 14th December 2018. Special incentives for indigenous OEM and EV manufacturers were announced under FAME. Many state Many state government like Delhi, Maharashtra, Tamil Nadu have announced the state policy to adapt EV. India also the member of Electric Vehicle Initiative EVA Multi-Governmental Policy Forum. The EVA Forum was established in 2009, accelerate the deployment of electric vehicle worldwide and facilitate exchange between the policymaker and various stakeholders. Countries currently active in the EVA include China, Canada, Finland, France, Germany, India, Japan, Mexico, Netherlands, Norway, UK, US. The initiative is jointly led by Canada and China. The International Energy Agency serves as a EVI coordinator. NEMMP, National Electric Mobility Mission Plan. The Government of India launches the National Electric Mobility Mission Plan 2020 in 2013. In 2013 itself, they planned the NEMMP 2020. It aimed to achieve national fuel security by promoting hybrid electric vehicle in country. There is an ambiguity target achieve 6 to 7 million sales of hybrid and electric vehicle year on year from 2020 onwards. Government aim to provide the government aim to provide the incentive kickstart nascent technology with the support form. The government and cumulative sale is expected to reach 15 to 16 million by 2020. It is expected to save 9,500 million liters of crude oil equivalent to rupees 62,000 crores saving. Government has launched to the scheme, namely faster adaptation and manufacturing of hybrid electric vehicle, FAME India under NEMMP 2020. Union budget for 2015, sorry, 15-16 with an initial outlay of 75 crores with the unwe- unweaving that the early market creation through the demand incentive, in-house technology development, and a domestic production with the help of industry reach self-sufficient economic scale in the long run by ministries involved in them: Ministry of Heavy Industries and Public Enterprise, Ministry of Power and Renewable, Ministry of Urban Development, Ministry of Finance, Ministry of Road and National Highway, Department of Science and Technology, DST. So these are all the various ministries involving for development of and promotion of the e-vehicle technology as well as the hybrid electric vehicle technology. The FAME for faster adaptation and manufacturing of hybrid electric vehicles in India. The FAME India scheme is an incentive scheme for the promotion of hybrid electric vehicle technology in India. Ultimate objective of scheme to promote electric mobility, and the scheme gives financial incentive for encouraging the consumers to use the electric vehicle. The FAME was launched the Ministry of Heavy Industries and Public Enterprise in 2015 to sensitize the production of eco-friendly vehicles, including the scheme operation having the two phases. The phase one started in 2015, was completed on March 21st to 2019. Phase two started in 1st April 2019 and it completed by 31st March 2022. So these are all the phase one and phase two for FAME for promotion of the e-vehicle technology, the incentive schemes, whatever it is. So the FAME India phase one, the phase one of FAME India scheme was launched in April 1st, 2015, extended to March 31st. These things already you know. The scheme was implemented with the outlay of 795 crores, approximately 2,18,625 electric vehicles were promoted by FAME 1 till July 2018, and the main objective to provide demand incentives. The mother program of FAME, the National Electric Mobility Mission Plan 2020, was launched in 2018, achieved sale of 6 to 7 million unit of electric vehicles, thus realized the fossil fuel saving of 2.2 to 2.5 million tons. Initial average coverage: cities under smart cities initiative, major metros, all state and other urban agglomeration, that is the cities with the 1 million or populations, cities with the northeastern states, these are all the target places. The FAME India, yes, this is already. So the FAME India, the fund allocations are, so the demand incentives are 1 lakh, sorry, 15,555 is the demand incentives. Then technology platform is 7,024. Then we have the charging infrastructure is around 104 or 10.4 percentage. The pilot project are 5.2, sorry, 20.8. Then IEC operations are 5.2. So these are all the fund allocations for the FAME India for promotion of the e-vehicle technology. In 2016 and 17, this is the fund allocation for FAME. So the phase two is a higher investment. The second phase expended for version of the first phase. It is outlay of 10,000 crore over the period of 3 years. That is 2019 to 22. The allocation scheme for 1920 estimation for 1,500 crore, 5,000 crore for 2020-21, and 3,500 crores for the last period, that is 21-22. So here we have a FAMT will cover the buses using EV technology, electric plug-in hybrid storage, hybrid four-wheelers can be introduced. The FAME one is only concentrating the two-wheeler as well as the three-wheeler. The FAME 2 is a four-wheeler concentration. So the project implementation and the sanctioning committee is giving a lot of subsidies and the subsidy policies for the promoters as well as the buyers, that is the consumers. So the implementation process of phase 2, the component demand incentives, yes, this is a outlay of the funds. Yeah, FAME 2 demand incentives for buses, it is only for buses, four-wheelers. Three-wheeler and two-wheeler rickshaws are in a FAME 1. FAME 2 demand incentives to meet the qualify the criteria for demand incentive, the hybrid electric vehicles, including its variants and versions, be manufactured the country have such percentage of localization as may notified from time to time. Meet the provision contain. Madam, next slide. Central motor vehicle rules in terms of type of approval, classification, categorization, definition, next slide, ma'am. Road worthiness, registration, etc. Obtain the certificate of Firm India Phase 2 eligible fulfillment for recognition of testing agencies, setting up of the charging station, etc. Ma'am, next slide. Should approximately display the stickers indicating the vehicle has been purchased under the scheme. So these are all the FAME demand incentives. Next slide, ma'am. So the other notifications are the scheme envisages the support for setting up of the adequate public charging infrastructure to install confidence among the EV users through the active participation and involvement of various stakeholders, including government agencies, industries, public sector enterprise. Flexibility of funding for establishment of charging infrastructure to the extent of 100% cost depending upon project proposal shall be available for promoting electric mobility. The scheme will implement with the help of the proper knowledge, technical expertise, which will be chosen for through the competitive bidding process. The suitable IE's information education communication program will undertaken to create consumer awareness, riding promotion, need basis through the education and the training, publicity, organization of the business meets, seminar, conference, symposia. We can promote the e-vehicles. Next. The charging infrastructure for electric vehicle guidelines and standards. To enable faster operation of electric vehicle in India by ensuring the safe, reliable, accessible and affordable. The charging infrastructure and the ecosystem to promote affordable, traffic chargeable from EV owners and the charging station owners, operators and owners to generate employment, income opportunity for small entrepreneur. Public charging infrastructure minimum requirements. These are the minimum requirements. An exclusive transformer with the all rated substation equipment, including safety appliances. 33 bar 11 line, either overhead or underground line cable, with associated equipment, including need for line termination, metering, protective devices, appropriate civil work, adequate spacing for charging and the entry and exit of vehicle. Current international standard that prevent and use most vehicle manufacturers internationally across the CCS and the CH. Hence, the public charging stations allow one or more electric NOS boards with the installation of the charge models. We have a charge fast charging, slow and moderate charging. So, and its capacity of rated voltage and the number of charging points per number of charging guns. Next, public charging infrastructure minimum requirements are Kinos bar boards may have the option to install additional charge if required. The public charging station provides are free to create charging hub and, and to install additional number of kiosks charges additionally minimum number of the charging prescribed. Tie up with the at least one online network service provider to enable the advanced remote online booking of the charging slots by the EV owners. Such online information to EV owners should also include the information regarding the location, types, and the number of chargers installed, available, etc. Appropriate public amenities were, in addition to the above, the fast charging facility also planned to provide the PCS by PCI provided the following adaptation environment. Appropriate liquid coolant cable if high-speed charging facility for onboard charging is also needed. Appropriate climate control equipment for fast charging batteries to be used for swapping of the batteries. Sometimes some critical condition already the charging station having the charged batteries, they can able to swap the battery and charge. So such kind of features also there. Location of charging infrastructure. In case of public charging stations, the following minimum requirement are laid down with regards to density and the distance between two charging points. At least one charging station should be available in the grid of 3 cross 3 kilometers. Further, one charging station should be set up at every 25 kilometers on both sides of highway roads. For long range EV, heavy duty EV like buses, trucks, etc., there should be at least one fast charging station with the charging infrastructure specified as standards every 100 kilometers, one on each side of the highway roads. Within cities, such charging facilities for heavy duty FE shall be located within the transport nagars, bus depots, etc. Business model for charging infrastructure, the EV infrastructure, charging, battery swapping. There are two methods. One is a charging mode, another is a battery swapping mode. In charging is onboard charging and offboard charging. Onboard charging AC charging spots, private car. Offboard charging is a DC charger, private car and public car. Battery swapping, the commercial vehicle, the passenger car. Side swapping, rear swapping, bottom swapping. These are all the where the places where the batteries are provided in the vehicles. Public bus sanitation vehicles, இது பார்த்தீங்கன்னா வந்து private car and taxi. These are all the EV charging infrastructure. The battery leasing and swapping scheme, it helped the consumer concern about the battery durability and performance while simultaneously reducing the initial upfront EV purchase price. The service providers retain the ownership of batteries. This model put the operational cost of EV on par with the conventional ICE. It allows manufacturers to retain ownership of battery for various second life application would provide additional values. Manufacturers, battery suppliers, and the service operator can partner to collectively develop battery swap or switching stations. Infrastructure service model, public infrastructure model, private infrastructure model. Public infrastructure model provides EV station at public parking space near to playgrounds, etc. Only EV are allowed to park this spot. They are likely to be act as an incentive to consumers in urban cities. This model will help to support the local municipality in partnership with the infrastructure provider. It seeks provide access to charging for those consumers that lack home charging. Private infrastructure model more preferable in the early stage of EV adaptation as it responds to direct consumer demand. Involve installing charging point for EV adaptation and their residents. This ensures higher usage of charging point based on the actual demand as reflected by EV purchase, thus providing a greater return on investment. End-to-end solution. It involves close partnership between the OEM, infrastructure facility provider, maintenance service provider, and local government. Provide consumer with an integrated package of end-to-end value-added service, thereby minimizing the number of interfaces that the consumer has to manage. Evolve as a subscription service where EV adaptation pay a monthly or annual fee for integration service package that involves access to charging facility. Present and future of electric vehicle technology in India. Government, regulatory bodies, automotive manufacturers, digital technologies, the charging infrastructure, battery technology, users, public sector market, mobility service provider, market action. So these are all the players for development of the EV into the market. So the first one is the government schemes, regulations, subsidies, everything. Niti Aayog, Ministry of Road Transport, Highways, Ministry of Heavy Industries and Public Enterprise, all these things are having the first step. They are the key persons. Next one is the automotive manufacturers, Mahindra, Ashok Leyland, Bajaj, Ather Energy, Ampere Vehicles, Hero. So these are all the automotive manufacturers are manufacturing the e-vehicles and its accessories. Then digital technology for payment mode, charging payment, everything. So this is very simple, it is available. Next one is the charging infrastructure on road, off road, swapping of batteries, whatever it is. Then the battery technology, we have the variety of batteries are available in the market, you can utilize. The users, public, private, government agencies, all these things. The future of EV in India, to report by Bloomberg New Energy Finance, says the India will be a better progress on electric two-wheeler, rickshaws, electric buses over the next 10 years. Report believe that 2040 EV will continue only 40% of the total passenger vehicle fleet in India. At the end of 2017, there were just 6,000 highway cabled electric car playing on Indian road, which is minimum number when compared with the overall number of the total cars in Indian road. BNEF study says the annual sale of EV, which will reach 30,000 units in 2022, has opened to 2,002 units in 2017. In 2017, it was 2,000. In 2022, it will be 30,000. If the sale of EV grow in study as predicted, they will continue about 6.6% of annual vehicle sale by 2030. It is go up to 27% by next 10 years. Also, by 2040, about 13% of the passenger vehicle playing on Indian road will be electricity by 2040. Even in 2040 itself, only in India we have 13% of vehicles are replaced by electric vehicle. That is the conclusion. So suggestions for developing EV market in India. The government need to implement significant subsidy scheme and put up mandatory will which will encourage car buyers to look at electric vehicle. The next most important thing is to develop a good network charging infrastructure across the country. Good idea will be to involve private players in this as well, although that is easier said than done. The factors such as the unreliable electric supply, lack of coordination between the different government levels, a lack of demand of EV keep private players away from investing in the charging infrastructure. The government should try to convert schemes such as Make in India initiative with the EV policy. EV stakeholders should come up with a robust business model for charging infrastructure and for EV such as retrofitting and etc. So this is the Tamil Nadu EV policy. Scope of policy, it covers the battery EV and hybrid EV, that is a battery operated EV and a hybrid EV. The policy is valid for the period of 10 years till new policy is announced. The policy measures electric cars and two-wheelers, EV shared mobility, that is a shared auto, EV in public transportation, EV in educational institution. Nowadays, many of the education institutes using the electric vehicles. Okay, you have a third session. I know within 1 minute I will finish it. So they are given the demand side incentive, 100% road tax exemption till 2022. Registration charges waived off as per the GOI, Government of India notification. Permit fees waived off for commercial vehicles. So this is about the tariff for charging station. So the private charging station, the cost around 1.5 rupee to 5 rupee per unit based on unit consumed. So these are all the some of the incentives are announced by the government, Tamil Nadu government. So the electricity tax exemption, 100% exemption for 2025 for EV manufacturing and setup of the charging station. Charging station setup person, they don't to, no need to pay EV bill to the government up to 2025. Then stamp duty exemption also there. That is a 100 percentage exemption for up to 2022 for land for sale as well as the lease. Thank you. I think you have. So I thank the management principal and the department of ECE for giving me the very good opportunity to share my thoughts in the field of electric vehicle technology and scenario for e-vehicles in India as well as the Tamil Nadu. Thank you.
Thank you, sir. I thank all the participants. And the next session starts by 11:40. Thank you.
Thank you, ma'am. Shall I
Yes, sir.
leave? Okay.
Yes.